NASA's Solar Dynamics Observatory has been observing the sun since 2010. They take pictures of the star in multiple wavelengths to study each layer of the solar atmosphere separately. In these photos, we can see the sun in all colors of the rainbow, and it looks impressive. Just imagine if we could see a blue or purple sun in the sky. The colors on the planet would no longer look the same. Green plants would turn blue, yellow would turn pink, and red would turn gray. However, we would hardly notice that because a change in the color of the sun would undoubtedly take its toll on humanity. So, what will happen if the sun changes its color? Sun belongs to the category of stars known as yellow dwarfs, whose mass is about 2 quintillion kilograms, and the temperature doesn't exceed 6,000 kelvins. From Earth, the main star of our system looks yellow, but from space, it appears white. So, what is the actual color of the sun? To figure it out, let's see what the essence of color is. All the colors we see are actually electromagnetic waves of different lengths. Nevertheless, a tiny percentage of these waves are in the visible spectrum. Most of them, like radio waves or ultraviolet radiation, remain invisible to us. And the sun emits radiation in every part of the electromagnetic spectrum. It turns out that it shines with all the colors at once, both known and unknown to us. But at the same time, if you look at the spectrogram of sunlight, you can see peaks in the range of 500 nanometers. This means our sun is actually blue-green. But two things prevent us from seeing this, one of which is Earth's atmosphere. Due to its composition and density, it scatters blue light well, transmitting primarily red light. Green is a mixture of blue and yellow. As blue light passes through our atmosphere, it gets scattered, and we see a yellow sun in the sky. And if our atmosphere were 10 times denser, there would be even less of the B color around. The sky would appear bluish-green, and the sun would look bright orange. But if the atmospheric density decreased, we would observe a bright and intense blue sky and a pale yellow sun. But even if we leave Earth, our star will still not look green, and that's the fault of the particularities of human vision. Since the sun emits light across the entire electromagnetic spectrum, our eyes just don't see a slight excess of green light. That's why it seems white from space. But if the sun emitted light only in the green part of the spectrum, our world would look totally different. The human eye can detect visible light with a wavelength ranging from about 380 to 800 nanometers. But under daylight conditions, our eyes are most sensitive at a wavelength of 555 nanometers, which is a yellow-green color. We perceive it as more vivid and saturated than other colors, so the light from the green sun would probably distort our visual perception of the outside world. For example, the sky would become light green instead of the usual blue, and at sunset, we could observe dark green and brown-red gradients. The green light has a shorter wavelength than yellow or red, therefore it'll greatly dissipate in the atmosphere. It means that the light from the green sun would be very faint. A day on Earth will be more like twilight, and it'll deeply impact the plants because they need a lot of light for photosynthesis. Most deciduous trees are unlikely to survive in new conditions. Conversely, conifers and lichens, mosses and ferns will feel comfortable. But in addition to eternal twilight, plants will have to adapt to lower temperatures. The green sun would greatly influence the climate on Earth, since only a modest amount of green light would reach the planet's surface. The average temperature here would drop by several degrees. Humankind would have to live in a gloomy and cold world, where everything is bathed in green light. And although it resembles a scene from a horror movie, the green sun is by no means the worst option for us. You see, the color of the sun affects not only its appearance. Depending on the spectrum in which a star radiates, we can determine its temperature and type. For example, whether it's a white dwarf or blue giant. Thereby, the color changes a star's mass, brightness, and amount of heat it emits. And one of the most dangerous colors for humanity could be red. If you wake up one morning and see that the sun in the sky is turned red, beware that our Earth has only a few million years left to exist, and humanity risks disappearing much sooner. The issue is that the red color means that the sun has begun its transformation into a new star type, a red giant. And at first, we'll notice only visual changes. The sky will turn from blue to red-orange. We'll no longer see green leaves, since all shades of this color will turn mush brown. And the seas and oceans will seem dark blue, almost black. But over time, people will feel other changes. The sun will begin to turn into a red giant when its core runs out of hydrogen, the fuel for thermonuclear fusion. As a result, our star will start expanding, and its surface temperature will drop to 3,000 to 5,000 kelvins. As the sun expands, its radius will increase by 110 million kilometers. It'll consume Mercury, Venus, and Earth, and stop just a little before reaching Mars's orbit. However, according to some estimates, this process could take from 100 to 150 million years. So, humanity will have enough time to experience all of the consequences. Moreover, a catastrophe will begin long before the sun comes close to us. Here's the thing, every star has a so-called habitable zone. This is a conditional region in the universe where the temperature is high enough to support liquid water. It's believed that such environments can host life. As you may have guessed, our Earth lies within the sun's habitable zone. But when our star begins transforming into a red giant, this region may shift. Although the sun will cool by several thousand degrees, due to the expansion, it'll move closer to Earth, and the temperature on the planet will constantly rise. But that's not even the most frightening thing. In fact, the greater danger to humans is the intense radiation and stellar wind, stream of charged particles erupting from the surface of the star. They'll interact with Earth's atmosphere, dispersing it and leaving the planet defenseless against solar radiation. Without the atmosphere, the oceans will quickly evaporate, and our Earth would become a lifeless chunk of rock long before the sun consumes it. Luckily for us, the sun will begin to transform into a red giant no sooner than 5 billion years from now. But even if our planet manages to survive this event, there will be no chance of reviving life there. After the red giant phase, our sun will become a white dwarf. That's the end of the road for a star. The sun's diameter will decrease to around 700,000 kilometers, and its surface temperature may reach tens of thousands of kelvins. The star's luminosity will decrease by almost 10,000 times. That's because the star's light is now a side effect of high temperatures, not the product of a thermonuclear reaction. Besides, a planetary nebula may form around a white dwarf. A planetary nebula is a cloud of gas and dust left over from a red giant's corona. The light from that sun would barely reach Earth. But at the same time, our planet was lucky to form in the solar system. Because if the sun were a star of a different type, like a blue supergiant, humanity would have had to fight for its survival right from the start. If you wake up one morning and see an incredibly bright blue sun, immediately go down to the basement or any other underground shelter. The blue glow means that instead of a yellow dwarf, blue supergiant calls the shots in our star system. It's an extremely bright and hot star. Its temperature can reach 50,000 kelvins, and its mass ranges from 10 to 300 solar masses. And the luminosity of these stars can be many times greater than that of the sun. For example, the blue supergiant star Rigel from the Orion constellation shines 130,000 times brighter than our sun, although its temperature is only around twice that of our sun, around 12,000 kelvins, whereas the star Eta Carina from the Carina constellation, which is 7 times hotter than the sun, shines 5 million times brighter. Blue supergiants form when massive stars run out of hydrogen and nuclear reactions stop. Then, instead of expanding like a red giant, the star, on the contrary, contracts. Its surface area decreases, and the radiation density becomes higher. Due to this, blue supergiant is heated to unbelievable temperatures. The stellar wind emanating from it accelerates and collides with the slow and dense stellar wind of the former massive star. These particles form the outer envelope of a luminary. And if Earth orbited such a star, we would observe many interesting effects. Our sky would acquire a pearl hue. The warm colors would look cooler. All plants would grow closer to the ground, and their leaves would become dense like those of succulents. That's because much more light will reach our Earth. At the same time, the temperature on the planet can rise to critical values. But even this is not the worst part. The thing is that the blue supergiant generates powerful ultraviolet radiation, and if humanity remains undestroyed by high temperatures, we'll face insomnia. The fact is that blue spectrum light affects hormone production in our brains. In particular, we produce less melatonin, which triggers the process of falling asleep and regulates circadian rhythms, the so-called biological clock. Chronic sleep deprivation can lead to hypertension, heart failure, and even contribute to the onset of diabetes. But that's not all. High doses of ultraviolet radiation can cause burns on the skin and retina. In addition, these rays initiate photoaging processes. The skin stops producing collagen and loses its elasticity. Pigment spots and wrinkles start appearing on it. So, if our sun were a blue supergiant, people would look old already in their teens. On top of that, ultraviolet rays can penetrate the skin and break the bonds in DNA molecules. And when a lot of such damage is accumulated and the body can't cope with fixing it, it can lead to cell death and the development of skin cancer. But if people could hide from deadly rays underground, no shelters would save us from plasma emissions. Plasma ejections resemble coronal mass ejections that sometimes occur on our sun. Such flares can disrupt Earth's magnetosphere, cause interruptions in communications and power outages, damage satellites, and even provoke dramatic changes in the radiation belts. Now, imagine a similar plasma ejection, but tens of thousands of times more powerful. Its consequences are hard to even imagine. Blue supergiants have a relatively small lifetime, only 10 to 50 million years. Due to their immense mass, high temperatures, and brightness, these stars rapidly burn out. For reference, when life on Earth began, our sun was 800 million years old. If it were a blue supergiant, it would have long ago turned into a supernova, and then into a neutron star and a black hole. And if the sun had been transformed into a neutron star, our Earth would have been torn to pieces in the first few seconds. All because the gravitational force of such a star is 2 billion times stronger than Earth's. Stars of this type are usually tiny, only a few dozen kilometers in diameter. However, their mass is 1.5 to 2 times our sun's mass. The average matter density of a neutron star is about 400 million tons per cubic centimeter. In addition, it spins around its axis around 700 times per second. For comparison, the sun makes a complete revolution once every 27 days. If it suddenly becomes a neutron star, all the planets of our system would be instantly pulled close to it and ground into dust. But what if the sun turns into a black hole instead of a neutron star? Our end will probably be just as quick. Or not. Theoretically, the sun can become a black hole only in 2 cases: if it gains enough mass or gets devoured by another black hole. Fortunately for us, the sun doesn't have enough mass to collapse into even a tiny black hole. And if it engulfs all the planets in our system, including Pluto, that still wouldn't be enough. The sun needs to increase its mass at least tenfold to have a chance to go supernova and then transform into a black hole. It's far more likely that a so-called rogue black hole will enter our system, swallow the sun, and take its place. In January of 2022, a team of astronomers working with the Hubble Space Telescope first discovered such a black hole. Its mass is almost 7 times that of our Sun. It's only 5,000 light-years away from us and speeds through space at 45 kilometers per second. If this black hole consumes our Sun, the Earth and its solar system will also be pulled beyond the event horizon. But if our star is replaced by a black hole with the same mass as the Sun, then the planets will continue to spin in their orbits. Such a hole will absorb only objects within a radius of 1,700 kilometers around it. But our planet will no longer receive light and heat from the sun. In 24 hours, plants will start dying on Earth. Large trees will be able to live for a few more years, but most of the greenery and herbivores will quickly die. From that moment on, humanity will have a limited supply of oxygen. We annually breathe in about 6 trillion kilograms of this gas, and our atmosphere contains about 1 octillion kilograms of oxygen. These supplies could last us for a few trillion years, but would humanity manage to survive this long? Just a week after the black hole replaces the sun, the average temperature on the planet will drop to 0 degrees Celsius. By contrast, today's average global temperature is 14 degrees Celsius. However, people will suffer not only from the cold snap. Exposure to sunlight increases the brain's release of a hormone called serotonin, which regulates mood. Low levels of this hormone are associated with an increased risk of depression, anxiety disorder, and panic attacks. In addition, vitamin D is produced in the human body during exposure to sunlight. Its deficiency can lead to bone-destroying diseases such as osteoporosis. In a year, the average temperature on Earth will drop to minus 73 degrees Celsius, but humans will still be able to survive. To do this, we'll have to establish settlements near geothermal vents, for example, in Yellowstone or on the territory of modern Iceland, all because the only remaining source of heat for us will be around Earth's core. It produces around 20% of Earth's total thermal energy. To survive, people will have to move closer to volcanic vents, geysers, and hot springs. In 3 years, all the oceans on the planet will be covered with a crust of ice. 10 years later, the air will start to become liquid due to extremely low temperatures. Earth will be exposed to rains of frozen gases, but people will still have a chance. To survive, we'll have to move underground and use oxygen tanks for breathing. In millions of years, the surface temperature will drop to minus 270 degrees Celsius. By that time, there will be no living organisms left on the planet except for tardigrades. They can tolerate frosts of minus 272 degrees Celsius, but events could develop in a completely different way. If an accretion disk forms around a black hole that will replace the sun, its radiation could be sufficient to maintain an acceptable temperature on Earth. The material in such disks is compressed during rotation and emits heat due to the friction force. However, the accretion disk of the black hole will probably radiate in the X-ray part of the spectrum. Simply put, the light from such a disk will be radioactive for us. The scientists claim that the sun will begin transforming into a red giant no sooner than 5 billion years from now. But there are those who already notice that the color of our star is changing. An increasing number of people are reporting that over the past few decades, the sun has changed its color from yellow to white. Have you noticed that? And what could such a transformation mean? Write in the comments.